Hello and welcome to the 11th video lecture of Operations Research Semester 4 Module number 3. In today's video lecture, we are going to study about one more problem on matrix minima method, also known as least cost method, and find out its IBFS, that is initial basic feasible solution. So let us begin. The problem is like this. uh, Determine the IBFS using matrix minima method. So they have asked us to find out the IBFS using matrix minima method. Now this is the problem that they have given here: warehouses and factories. So as we already all know that products or items will move from factories towards warehouses. So from is always on the left hand side and 2 is always on the top. Remember this system of writing your transportation matrix. From, that is sources, is always on the left hand side, and to, that is destination, is always written on the top. So factories, we have 4 factories: F1, F2, F3, F4, and 3 warehouses: W1, W2, W3, and unit transportation costs are given. Remember, these are unit transportation cost, that is to transfer 1 unit of item from factory 1, that is F1 here, to warehouse 1 here. You require 5 rupees, or you have incur a cost of 5 rupees. 1 unit can be anything, one number of item it might be, or it might be 1 liter of a item, 1 kg of item, 1 ton of item, anything it can be. So packaging size can be anything, but 1 unit of item to transport from F1 to W1, that is factory 1 to W1, is 5 rupees. Similarly, to transport 1 unit of item from factory 3 to warehouse 2, factory 3, here it is, to warehouse 2, so it will cost you 6 rupees. So this is how your problem is there stacked. Supply sources are given here, that is total supply, and total demand is also given here. Okay, so what you are supposed to do is, first thing is, you have to first find whether the given problem is balanced or not. If it is balanced, only then you can solve the problem. If it is not balanced, then you have to first balance the problem. So let us first see whether the given problem is balanced or not. So how do you check whether the given problem is balanced or not? You have to add up all the supply sources, and you have to add up the total demand. If the total of supply is equal to total of demand, then we say that the given problem is balanced. If it is not, then we have to balance it. How to balance it, we are going to see in future problems. So let us see how to solve this and check whether it is balanced or not. Here, find out the total demand. Total demand is, you are adding up all these things: 5 plus 25 plus 30, and then also find out the total supply, this. So that is what I found out. Total demand is 60, total supply is 60, total demand is equal to total supply, and therefore we say that the problem is balanced. A balanced transportation problem is a problem where the total supply is equal to the total demand. So in this case, the given problem is a balanced transportation problem, and hence we can proceed. Okay, always before going and before solving a transportation problem, remember that you have to check whether the given problem is balanced or not. So let us concentrate on our given problem. Our given problem is this, just like how they will give you in a question paper. We are supposed to use matrix minima method or least cost method for this. Okay, so MMM or LCM, we have to use it. So when we are using it, what is it? Concentrate on the cost matrix. This is your cost matrix. Now least cost method, that is, which is the least cost out of this matrix, you have to find out. Matrix minima method also says that which is a minimum element or minimum unit transportation cost out of this matrix. So which is the lowest number in this minimum number? The minimum number is here, so you have to allocate here. Fine. 2 is the lowest number out of this, so you have to allocate here. How much can you allocate here? How much can you allocate? You can allow, you have to see what is the supply here. The supply here is 22. What is the demand here? Demand here is 5. So minimum of supply and demand you have to allocate here. So what is the minimum of supply and demand? Minimum of between 25 22 and 5 is 5. So you have to allocate 5 here, right? That is what I have done here. So I have allocated 5 there. Once I have allocated 5, what was the total supply here? 22. Out of that, 5 you have already supplied now. Here you have supplied 5. So what is the supply remaining now? The remaining supply is 22 minus 5, that is 17. And the demand here, how much was the demand? The demand was 5. You have fulfilled 5 units of demand. So what is the remaining demand? 5 minus 5, that is 0. So you have to cancel, that is you have to subtract whatever you have allocated from both the demand and the supply side. So that is what I have done here. Whenever a row or a column becomes 0, we have to cancel it out. So here this row is becoming 0, so just cancel this out. Fine. Now concentrate on the remaining cost matrix. This is the remaining cost matrix now. These elements are gone, so don't consider these elements now. Now only consider these elements. Okay. Now which is the lowest element? Again the same step. Lowest element out of this matrix. The lowest element of this matrix is 3. So you have to allocate here. How much can you allocate? You can allocate minimum of supply and demand. What is the supply here? It is 20. What is the demand here? 25. So minimum of supply and demand you have to allocate here, that is 20. What is the minimum value of 20 and 25? It is 20. So allocate 20 here. Fine. So I have allocated 20. Once I have allocated 20, I have to subtract 20 from both supply as well as demand. So I have to cancel. So 20 minus 20 is 0 and 25 minus 20 is 5. So whenever any row or column becomes 0, here this is becoming 0. So I am cancelling this row out continuous. Now what is the remaining cost matrix? The remaining cost matrix is this much, that is uncancelled. So which is the lowest cost element out of this? The lowest cost element out of this is 4. So you have your next allocation will be here. How much should you allocate? Again, minimum of supply and demand. What is supply, remaining supply here? 17. What is the demand here? 5. So least out of 5 and 17 is 5. So allocate 5 here. Okay. So you have to allocate 5 here. Once you allocate 5 here, like this, what will be the remaining supply here? 17 minus 5, that is 12, and 5 minus 5, that is 0. Fine. Now this is becoming 0, so you have to cancel this entire column. After cancelling, out of the remaining cost matrix here, only this was remaining. Which was the least element? The least element was 6. So allocate here. How much should you allocate? Minimum of supply and demand. Supply was 8, demand was 30. So I have allocated 8 here. So once I have allocated 8 here, I have to reduce 8 from supply as well as demand. So 8 minus 8 is 0. 30 minus 8 is 22. This has become 0. So I am cancelling this row. Now what is remaining? Only this much. So out of this remaining, which was the least element? The least element was 8. Minimum of supply and demand there is, supply was 10, demand was 22. So I have allocated 10 here, that is least out of supply and demand. So 10 I have allocated here. Once I have allocated 10, I have to reduce 10 from here. 10 minus 10 is 0, 22 minus 10 is 12. So now once this has become 0, I am cancelling this entire row. Now, which is the element that is remaining? There is only one element that is remaining in this cost matrix, that is 12. So I have to allocate there only by default. I do not have any other option. What is the supply there? 12. What is the demand there? Also 12. Minimum of supply and demand is 12. So what is the minimum between 12 and 12? If I ask you, the answer will be 12. So you have to allocate 12 here. If you allocate 12 here, what will remain here? 12 minus 12 is 0. 12 minus 12 is 0. So both the supply and the demand of this becomes 0. So cancel it out, allocate 12. This becomes 12 minus 12 0. This becomes 12 minus 12 0. So in this case, both the supply and demand are getting 0. So cancel both the row as well as the column, because both are getting 0. So I've cancelled it out. Now check whether all the rows and columns are cancelled. Here in this case, we see that all the rows and columns are cancelled out. Fine. So I cancelled out. And what is the demand remaining? Anywhere the demand is remaining? No. All the demands are 0. And what about the supply? All the supply is 0. So that means you have allocated properly. The next step is to find out the transportation cost. So I'll draw a table and I'll show how I have allocated. See here, total allocations here are 1, 2, 3, 4, 5 and 6. Total 6 places I have allocation. So I'll draw this table like here: factory, warehouse, transportation cost. So let's go back to this factory F1 to W3, the first allocation, F1 to W3. That is, what is the transportation cost there? 6 was the unit cost. Total allocation were 8 units. So 6 into 8 is 48. That is what I have written. The next allocation here was this, that is from factory 2, F2 to warehouse 1, so W1. So F2 to W1, and the allocation was, unit cost was this much, that is 2, and the total allocation was 5. So 2 into 5. Fine. So now similarly you have to do F2 to W2, F2 to W3, F3 to W3 and F4 to W2. Once you do this, find out the total transportation cost by adding up all these things. The total transportation cost for that I am getting is 338 rupees or units or dollars, whatever your units of currency you are using. So this is your final answer to find out IBFS. Now one thing you can see, when we are using northwest corner method and when we are using least cost method, there is difference in answer. So again I am telling you, if you are using different methods, you will get different answers, and in the same method also you may get different answers, because there is a possibility of getting multiple optimal solutions. So that is one of the thing in operations research. In most of the models you will get this kind of this, for one question you may get multiple correct answers. Okay, so this is how we solve least cost method or matrix minimum method. I hope you have understood this. If there is any difficulty, you have to call me between 6:30 and 7 in the evening. With this we end today's lecture.